Hello and welcome back to Statistics1. We are going to continue our Chapter 1 exploration, Section 1.3 on other sampling designs. Last time we talked about population being everyone, and then sample being a part of the population. Now, we also seen that same groups of people, individual or things, could be sample or could be population depending on what you are talking about. And I gave you an example that you as class could be population if I call for all students signed up for Stats Math 110 Section 06. Thank you. You will be the reference for the rest of the semester. And then if I just talk about all of the students taking stats at RVCC, you guys would be a sample. You would be a bad sample, but you would be a sample. And I'll explain why you would be a bad sample if I'm trying to talk about all of the students and use exactly just you as a sample. So now, talking about other sampling designs. So last class, which is 2 days ago, we said that we can come up with a sample by picking random numbers by either using a random number generator software, or you can use a random number table, which is given in the back of your textbook. We also saw the way it was used, right? You poke a finger somewhere on that table, and then you just go down and then snake your way up and then down. As many numbers as you need. You can use for 1-digit values, 2-digit, 3-digit, whatever you need. So that was a simple random sampling. Now we're going to take a look at systematic random sampling. So that will be the first part. And systematic random sampling would be a procedure to obtain a sample. But this one is called systematic because there is a way, there is a procedure that you follow to obtain the sample. So here in blood procedure. So you have population that you want to observe. You do not want to sample the entire population. We said that can be very expensive, time-consuming, difficult, even dangerous, right? So we are going to obtain a sample, which is a smaller part of the population, survey that, and then use inferential statistics to infer truth about population looking at the smaller sample. Now, the trick is to obtain a good representative sample that will, to its best of abilities, represent the population, represent the whole. Now, would it be good to just go and handpick individuals in your survey or whatever? The answer is obviously no. Because everyone is biased in some way. Some people would pick one type of people rather than the other because it's either easier or less scary or whatever. So there are reasons why you would do a terrible job if you go and just pick by just looking at the people, or picking a method that would enable you to quickly finish your sampling but exclude a lot of people from being in a pool to be picked. For instance, is it a good way to survey about elections by calling people? No. Most of the cell phones are blocked, and a lot of people today don't have landlines at all. Not a good idea. Is it a good idea to go door to door? for that survey? No, because you're going to park in a neighborhood and then just talk to the 5 random houses that are next door to each other because you're lazy and you don't want to walk, right? See, all of these are terrible ideas. And you know that you need to survey at least 100,000. So what are you going to do? Send a letter through mail because everyone has a physical address? Well, people tend not to read, if it has more than 7 words. And in addition to that, especially now that they want you to fill something in and then, put a 20-cent stamp on it and send it back. That also makes things worse. I don't know what the postage is. Just said 20 cents.
55.
I'm sorry?
It went up to 55 cents.
Went to 50. See? Now we're talking a quarter of a cat food can. So now that's assuming that the cat food can is $2.20. I don't know. I just tossed the numbers out there. Plus 10% tax. Now, let's take a look at the way to obtain a sample. So since we are so terrible in obtaining samples on our own, phone is bad, mail is bad, walking door to door is bad, you go to the mall and say, okay, the first 100 people that pass by me are the ones, right? No. Everyone goes to the mall? No. Rich people do. That's it. So that's pretty much, and those who are bored. I mean, it's just 2 demographics there, right? The rich and the useless. So what are we going to do? We're going to find a way to survey larger population by this systematic random sampling by following the procedure. Step 1 is divide the population size by the sample size. And round the result down. And round down. Now the procedure still says to the nearest whole number. Yeah, please go survey 2.5 people. I'm going to laugh forever, right? Especially when you go to a test and you say, okay, the mean number of babies in this hospital is 7.3. Really? 7.3 babies? Great. So if we are talking about units that are not subdivisible, like babies or people or dogs, you want the whole number, you want the integer. So it should be common sense, right? You round down. Parts, leave them as parts. Money has 2 decimals for cents. So 3.5 is fine. That means $3.50. That's okay. 3.5 babies, not okay, right? Unless you're North Korea or something. Now, step 2. Use a random number table or your software generator, whatever, to obtain a number between 1 and m. Okay, so, I forgot to say that this number that you get here is equal to m. Right, so you will set this number that you round down equal to m. So now use random number generator. So that would be either the chart in your textbook or Google or whatever. So use random number generator to obtain a number k between 1 and m. When we do example, this will be much clearer. Now it's a lot of red words. Step 3, select for the sample those numbers in the population that are k plus m, k plus 2m. So select for the sample those members of the population the desk can't hear you, it's okay. That are, it's not alive either, numbered k, k plus m, k plus 2m, k plus 3m, 4m, and so on. Good. This is the entire procedure. Now, to understand this procedure, we are going to run this particular procedure in a classroom. We can look at the statistics of either age, body weight, size of the shoes, I don't know, size of the head, whatever. So we can go and survey every single person in a classroom. What is your shoe size? That means census, surveying everyone, which is the population, and you are bound to run into issues. Issue number one is takes a long time. Issue number two, you're going to have someone who's going to be right, and it's just, you know, bad. So what do? Well, we can run this and then select a few people, and by using this procedure, we are not guaranteeing, but we are picking random, but we have a method to the madness, right, to pick the random sample. So let's say, first off, what do we have in the classroom? We have 5, and then plus 8 is 13, and then another 5 is 18, and over there we have 6. So we have 24 in the classroom. So capital, so this is now example. So we have capital N equals 24 students. If any one of you are not identified as a student, please leave. So that's N equals 24. And what would be the sample size that would be a representative sample size for 24? What do you think is enough? 6 people? Okay. Sample size, that's a lowercase n, 6. So this is population over here. So 6 of you will answer the question, what do we do? Age, shoe size, body weight, what should we do? Shoe size? Okay. Sounds good. Shoe sizes. So shoe sizes, great. Now, here we go. Yeah, I should have done it 5 so we can round down. Because 24 divided by 6 is 4 and it's not fun. So I'm changing the sample size to 5 so we can do this annoying division. All right, so what do we have? We have a population of 24, and now I change the sample size to 5 so we have annoying division. So step number 1 says that you are supposed to take 24 and divide that by 5. In our case, you are going to get 4.8. You are supposed to round down then to 4 because there are 4 whole units inside 4.8. So each group will have 4. This means M equals 4. M equals 4. Step number 2, use random number generator. That's the RNG. If you ever watch any of the video game streams or anything like that, they talk about RNG all the time. Random number generator. That's what it stands for, and a lot of games depend on it. If you have... I'm sorry?
Like the green tracks?
Yeah, people always say, "Oh, pray to RNG Jesus" and stuff like RNG Jesus, and so this is what it's just a lot of games. Let's say you play a game that has a drop rates for either cosmetic skins or better items in a game or whatever. If there is any kind of randomization, it's RNG, it's random number generator that provides that's going to be a drop of some kind. So that would be RNG. Some first-person shooters are even using random number generators for shots because involves some randomness, so it's not just skill. You have to be also lucky to be good. So these are the things that you have to work. So now we're going to use a random number generator. I'm going to just ask mighty Google. Random number. I know you can't see it, but trust me. Random number between 1 and 4. So we are looking for a random number between 1 and 4. Google will return 1. So Google said k equals to 1. So now we have m equals to 4 and we have k equals to 1. Number 3, we obtain our sample. Now this is what happens. We are going to create groups of 4 students because that's what M is. The first person in each group gets to say the shoe size. Then we skip the 3. Then the next person says the shoe size. Then we skip 3 and we obtain. Which means you will be telling me the shoe size, right? And then 3 in the back will say no shoe size. And then you, with the hat, will say the shoe size. The hat, not the hoodie. Good. Ooh, you double up. Damn, you're ready. You're ready for this. Then we jump over here, right? Again, the hat, right? Shoe size, skip 3, the hat again. Then we skip 3. And then Jack has no hat. Okay, so then you will be the shoe size. Skip 3, hat again. And then skip 3, no hat. And then, okay, good. So, there we go. That's how you obtain. So now just get the sample. Get the sample. It would be the numbers assigned to each student. We don't even have to deal with names or anything like that. We just deal with the position, the way you sit. And we say, okay, the first one is chosen, skip 3. Fifth one is chosen, skip 3. Then this one, skip 3. This one, and so on. So we are going to go through this pattern and pick these. So is this random? It is random because Google decided to pick the first ones, right? So the pattern started with number 1. The pattern could have started with number 2 or 3 because if I ask Google to give me this random generator number again, there it is. Google now returns 4. So Google is using random number generator to provide that number k, and then you start with that value and you go through each one of these groups because your M, right, the size was 4, so we are going to have, oh no, hold on, your sample size is 5. Oops, I'm off by 1. Your sample size is 5. I lied. That's much better. Okay. Sample size is 5. You skip 4. Sample size is 5 because we decided the sample size is 5. So 1 through 5. So that's all one group. So shoe size, skip the rest. Shoe size, skip all the way up. Shoe size in green. Skip 5, shoe size. And then skip 5. And again, You got it. It's a shoe size anyway, man. That's good. All right, so that's the way to systematically pick the sample while still having the element of random, because you are using random number generator to get this K, which will tell you where to start counting. The next procedure is called cluster sampling. So we go with the procedure. This is just a way to pick. So step 1, divide the population into groups, clusters. So this word groups, also known as clusters. Step 2. Obtain a simple random sample of the clusters. Step 3. Use all the members of the clusters obtained in step 2 as a sample. So where could you use something like this? Okay, so which group would you like to make in this class so we can run this as an example? I'm sorry? Okay, age range, to make sure that your sample, you see, now we're getting into trying to make a sample inclusive, right? Just by chance, if I am to run previous example, right? Just by chance, if I'm to run the previous example and Google returns, let's say, number 2 on a sample of 5, couldn't that just worked out to be female, 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 female? Could it? Right? It could. Would that be a representative sample, non-biased sample? No, right? It would be biased sample. So we would have to figure out another way. You would say, oh, okay, well, yeah, out of 24, we're roughly half and half in present right now, roughly half and half. Would you say, okay, well, we do have about 12 and 12, or maybe, 10 to 14. It's roughly half if you look around and count. To pick entire sample to be female, it would not be representative, right? Because what can you infer from that sample? You have a sample of size 5 that are all female. What do you immediately infer about the population of the classroom? all female, right? Now look around. See that? So, yes, the first method we learned, systematic one, right? Systematic random sampling, is random because we do ask for a random number. But by chance, in this classroom, we could have picked numbers could wind up, or the way you sit could wind up such a way that you can fill the entire sample with the same sex, for instance. So what we are going to do now is we are going to create groups. I still want the sample size. I still want, right? So all of that we learned before still holds, but now I'm going to create clusters. So I can create two clusters. There's a female cluster, and then there's a male cluster. Now if I have the two clusters like that, then I can find a sample in one cluster, pick 2 or 3 using the procedure, and then go to the other cluster and pick 2 or 3. And now that sample would be more representative of what we have in terms of the actual ratio, right? And then we can make better predictions, better conclusions, and better everything because the sample is more representative. So we have to be very careful in picking the sample. You don't get to just go and say, all right, who wants to participate? The people that want to do things, they are the ones that want to participate. Those who want to sit and do nothing, obviously they're not going to be surveyed, right? So you can't do that, right? You have to go and you have to bother the person to answer your survey because they won the lottery that you were running. They didn't even know, right? Now today people are trying to say, okay, if you participate in this survey, we will throw in your name, right? And you might win, I don't know, a house. And they say, well, of course I'm going to do this because, you know, I'm getting a free house. You're not, but still, you want to try. So for cluster sampling, there would be one way to divide students in this classroom, right, between male and female, and then run sampling on one cluster, run sampling on the other cluster, and then combine whatever you get from each cluster to create the sample. That's step 3. Now, in terms of, let's say, voting or whatever else, can you just call a town cluster, do the sampling in that town, go to the next town over, that's a cluster, right? And then go town by town, township by township, whatever way is divided, and then come up with a large sample for the entire state. And then you run your opinion polls and things for the voting or public issues or whatever else. So we can do clusters. If it's something local, we can do neighborhoods, right? Because, as I said, you're not going to have good representation if you drive to a location and walk around. There are parts that have condos, right? Parts that have single-family houses, and since we are in Somerset and Hudson counties, parts where you have those mansions, right? So, if you drive into any of the neighborhoods, right, you will get just to one type of people rather than surveying variety to actually have a good representation for everyone. So, clusters in this case would be, okay, here's the neighborhood, here's another neighborhood, here's another neighborhood. You can do it by town, you can do it by township, or whatever. So, you're creating clusters. And then those clusters. Okay, bike path surveys. To save time, the planner decides to use cluster sampling. The residential portion of the city was divided into 947 blocks, each containing 20 homes, as shown in the figure. All they have is this little greenery with 20 homes around. That's all it is. And I say, explain how the planner uses cluster sampling to obtain sample of 300 homes. So each contains 20 homes. So you can, the planner would use the 970 blocks of the clusters and dividing a population residential, right, into 947 groups. I get the error, so I don't get to read the next page. Yeah, I think the website died. Anyway. So, we had 947, I believe. 947 blocks. Each block had 20 houses. So you have to pick a sample of 300. That's a little bit small, right? If you have 947 blocks times 20 houses would be the number of houses. Each house would have, average 3 to 4 people live in them, and you just want 300. The website died, so I can't now see if they wanted 300 homes surveyed, or they want 300 individuals surveyed, because then you have to multiply that also. They say temporary fault. Now, this means that I'm going to hike. Going to hunt down the book. I'll be right back. Need this for my Google Maps. Yeah, 19 seconds, right? That's still broken. Yes. So they needed 20 homes. Perfect. Okay, so what are the clusters now? So we want 20 homes, and we want to survey 300 homes, and there are 20 homes in each block. Yeah, it's the number of blocks. Each block has 20 houses. So they want 20 homes. So they want to survey 300 homes. So 300 homes divided by 20 is 15 blocks. So I need to pick 15 blocks out of 947. And if I pick 15 blocks, then I would have, now, do I just go adjacent 15 so I don't have to drive? Right? That's the way to mess things up. So we pick up 15 blocks, and then we just go through steps, right? Now you know that you will be surveying 15 blocks. So if you're surveying 15 blocks, you need to pick which blocks you are going to survey. So you would divide, pick a random number, pick those blocks, and go on, just like we did for the shoe size. Yes? 20 was the number of houses in each block. So each block is like a little, circle or the block between the streets. Well, that's the population. That's the big number that you're dividing into. That's the number of blocks. You need 15 blocks. So now you unleash the procedure. So this is the setup. Now what you do is 947 divided by 15. Then equal to a number in this box, round down. Oh, well, thank you. That's very accommodating. 63, right? Then you ask Google, right, to give you a number 1 through 15. The Google is going to pick something. Let's say Google picks 8. That's your K equals 8. You have your M equals 63. So what do you have? Block number 8. Then 63 plus 8 is 71, right? And you pick your blocks. You go survey those blocks. Why did I say 15? Oops. Yes, you're right. It's Wednesday. Well, K-skill could be 8. You ask Google for a number 1 through 63. I'm going to ask Google, since the website exploded, I'm just going to leave it there. 1 through 63. And the Google says, there we go. Google says 37. Perfect. So, your first block out of 947 blocks to survey, the first one you're surveying is 37, the next one is 100, then the next one is 163. Yep. And then plus 63, that will be 220.
Oh, you just put 15 plus how many blocks you need per block?
Yes. So there will be 15 of these numbers
Okay.
by the time we reach here. So that's 226. You see, so each time you are adding 63, no copy. So we got this. Good.
That's step 1.
Sorry?
That's step 1.
Yes. So, well, this is step 1, 2, and 3. Step 1, step 2, step 3 of the first procedure. This is when we did the shoe sizes. And this stuff over here is dealing with blocks, which are groups. This is the second one. And this problem combined the two.
947 was total houses.
Number of blocks, and then each block would have 20 houses inside. Because by the time I was I started writing, the computer thingy died, and I couldn't get to see what the 20 was, number of homes or number of blocks. So I had to go get the book to actually match this. All right, I think that's good enough. Multistage sampling is just combine a whole bunch of these together. And then we're going to go now through 1.4 briefly to take a look at experimental design. That's just brief. And that's it. Okay, so actually, you know what? Let's run one homework example in 1.3 rather than just jumping immediately. In 1.4, we're just learning few words, and that's it. It's not as involved as, let's say, asking Google to find a number for us. So let's take a look at a homework assignment. Most of these are giving you actually everything, and then they're asking you to recognize which one of these was used. Trying to find one when they say, do it. All right, this is boring, but it is what it is. It's not applied. They just say that this problem is 160. Members of population have been numbered 1 through 500. So your population N is 500. So 1 through 500. A sample size of N equals 9. So sample lowercase n equals 9. It's to be taken using systematic random sampling. So there you go. So let's find the sample. So what is the first thing we do? Yes, we divide 500 by 9. Great. So 500 divided by 9 is 55. Well, 55 point. Yes. So we round down. So 55.55 repeating. We round down. So our M is equal to 55. So that's step 1. Step 2. Ask Google. You could have asked Google to solve the whole problem. You don't have to worry about anything, but all right, so Google, give me a number 1 through 55. Google says 15. Thank you, Google. K equals 15. So now the sample is 15. That's the first number. 15 plus 55 is 70. And then plus another 55 is 125. Plus another 55 is 180. And then 235. Then 290. And I'll put 3 dots. So you keep, well, actually no. Let's just get all of them, because we only need 9. I already have 6 of them. No coffee, we said. So that's 345, right? Then we have 400, 455, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. And now look what happens. If you are to add another 55, you're going to go over 500. You see that? If you add another 55, you're going to end up with 510. And that's not bueno because your population is 500. So this is your sample of 9. And then if these are, I don't know, rabbits, you will go and survey 15th rabbit because the 15th rabbit has the little tag on his ear that says 15 on it. I had to look through many rabbits to find that one, but yeah. You ask the rabbit to fill out the questionnaire and there you go, right? Good to go. Perfect. All right, that's it for this one. Bye.